So this is the continuation of our orthoptic series that I started. So today I will discuss with you all on AC by A ratio. Okay, so let's start. So what is AC by A ratio? The convergence response of an individual to a unit stimulus of accommodation is known as AC by A ratio. Every individual responds to a unit stimulus of accommodation with a specific amount of convergence. The convergence exerted by accommodation may be greater or lesser. That is called as convergence requirement. Okay. So what is the purpose of measuring this AC by A ratio? So the purpose is to determine the change in accommodative convergence that occur when the patient accommodate or relax. Okay, that is the main purpose of measuring accommodative by accommodation ratio. Okay, so how to measure this AC by A ratio? There is two ways to measure AC by A ratio. One is heterophoria method, another is gradient method. We will discuss these two methods today. Okay, so let's start from heterophoria method. So in heterophoria method, you need to measure the deviation for distant fixation with full correction of refractive error. Then measure the deviation for near fixation at 33 centimeter, and if you convert this 33 centimeter to dioptric value, it will be 3 diopter. Then you also need to measure the patient interpupillary distance. Also you need to measure the difference between this near deviation and distant deviation. Don't forget this sign convention. It will be very much useful for your calculation of AC by A ratio. Okay. For esotropia, you will use positive sign. For exotropia, you will use negative sign. Okay. This is the formula for measuring AC by A ratio in heterophoria method, where AC by A ratio is equal to interpupillary distance plus, this is the deviation of the eye for near fixation minus deviation for the eye for distant fixation divided by the fixation distance dioptrical value. Okay, so here I also given the explanation for that. Now let's go to an example, and after that we will see. So suppose the patient interpupillary distance is 6 centimeter, distant deviation is 2 prism exo, near deviation 8 prism exo. So what I told you, that if the patient is having exo deviation, you will use positive sign. If the patient is having exo deviation, you will use negative sign. So you need to use this negative sign in front of this 2 deviation for distant near and put the value to this formula. Okay, and you will get this value. This is 4. So you will call AC by A ratio ideal when the convergence requirement is fulfilled by accommodative convergence, and the normal range is in between 3 to 5 diopter. So if the value is more than 5 diopter, it indicates convergence excess, and if it is less than 3 diopter, it is indicating convergence insufficiency. Okay, so here it is in the normal range 4. So this is the another example where you can see this is the interpupillary distance 5.5 centimeter, distant deviation 4 prism ESO, near deviation 10 prism ESO. ESO means you need to use positive sign, right? Fixation distance 33 centimeter, 3 diopter. Now AC by A ratio, you need to use positive sign in front of these two, then put the value to the formula, and after that you will get AC by ratio, that is 3.5. Okay, so don't forget this normal range 3:1 to 5:1. That means in every diopter of accommodation there is 3 diopter of convergence is there. It can be 5 diopter also, 5 prism diopter. Okay, now let's move to gradient method. So this gradient method is also widely used in case of measuring the AC by A ratio, where it can be done by stimulating or relaxing the accommodation. Here the change in the stimulation to accommodation is produced by using ophthalmic lenses. Minus lens will induce accommodation and plus lens will relax accommodation. Why? Because whenever you are putting minus lens in front of the patient eye, then the eye shifted to hypermetropic side. So that's why the patient will induce his accommodation to make the focus on the retina. And if you are placing positive sign or plus sign in front of the patient eye, then the patient will shift to myopic side. So that's why patient need to relax his accommodation to make the focus on the retina. So that's why minus sign will induce accommodation, and plus sign will relax accommodation. So it is also said that minus 1 diopter of lens will induce 1 diopter of accommodation, and plus 1 diopter of lens will induce plus 1 diopter of lens will relax 1 diopter of accommodation, and the convergence is also there, right? So that's why we are going to measure what is the convergence by gradient method. So the process is measure the patient distant deviation without using any lens by giving patient best refractive correction. Here you need to make the patient fixate on a specific distance, then measure the deviation for that specific fixation distance without using any lens. Then add minus lenses. You can use -1, -2, -3, any of the lens in front of the patient eye. Binocularly measure the deviation with lenses. Now divide it by the dioptrical value of the lens, and also don't forget to use the sign convention. Okay, iso positive sign or plus, exo minus. Okay, so this is the formula where AC by ratio is equal to deviation of the eye for the specific distance for fixation distance by using lens minus deviation of the eye without using lens divided by the dioptrical value of the lens. This is the example where original deviation is 2 prism exo. Exo means you need to use minus sign. Now -2 diopter lens is put in front of the patient eyes, and that inducing iso deviation of 8 prism iso. So here 8 prism iso, so iso deviation will, it means positive sign, and exo negative sign. So 8 positive sign, 2 negative sign, put the value to this formula and you will get the AC by ratio, there is 5. So what I told you that 3 to 5 is in the normal range, so the patient is AC by ratio is also normal. Okay, so that's all friends, thanks for watching, please don't forget to like my video, subscribe to my channel, and I hope this video helped you to calculate AC by A ratio properly. Then also if you are having any doubt or query, don't forget to put the comment so that I will be able to clarify your doubts properly. Thank you so much.